Okay, so we're going to do magnitudes of earthquakes. And we're just going to show how exponential form and logarithmic functions kind of help us determine magnitudes of earthquakes, because magnitudes can be confusing a little. So true intensity, in other words, we're going to write these values out. 10 to the power of 1 is just a 10, so we call it a 10. And on the Richter scale, that's written as log 10, so 10 to the power of 1 is 10. Well, 10 to the power of 1 of 10 is still 10. True intensity, 10 to the power of 4, well, that's 10,000. On the Richter scale, that's considered a 4. So, a 1 on the Richter scale is a 10. A 4 on the Richter scale is not 4 times as large, but 10 to the power of 4 times as large. In other words, it's like multiplying by 1,000. Mm-hmm. So it's 1,000 times as strong. And if we were to jump up to 5, or in this case 5.8, this makes a bit of a different number, okay? So we're going to actually calculate the difference, the true difference between two values on the Richter scale. For instance, let's say we had a 4.5 on the Richter and an 8, okay? An 8 on the Richter. So how much more intense is the 8 than the 4.5? Okay, well, technically on the Richter scale, we're talking about a 10 to the power of 8. That's the true intensity, right? If we were to convert it to true intensity, because 8. So 8 should be written like this for a logarithmic function. So actually, I'll get rid of 10 to the power of 8 and show you how we actually did that. Technically, an 8 is log 10. 10 to the power of 8 is equal to 8. Okay? Well, its equivalent or exponential form of this is 10 to the power of 8, which is equal to 1, 2, 3, 4, 5, 6, 7, 8. So you're talking about 100 million. Okay? Pretty large number. So that's how we put it in our exponential form. So we're going to compare these in exponential form, which means the same idea with our 4.5. Log 10 is 10 to the 4.5, which is equal to 4.5. So in other words, that is 10 to the 4.5. And we want to know how much larger 8 is than 4.5. Well, we talked about this with HPs. In order to figure out how much larger or stronger something is, we take the larger value and divide by the smaller value. So we take our 10 to the power of 8, and we go into exponential form so it's easier to work with. 10 to the power of 8 divided by 10 to the power of 4.5. Well, I can simplify this exponent. Do you remember how to simplify these two exponents? The base can stay the same.
Oh, you cross multiply or something?
Not quite. Think of it like this. If we have x to the power of a divided by x to the power of b, I can simplify this by writing just xa minus b, subtracting our two exponents. So in other words, I take 10 and I subtract 8 minus 4.5. So in other words, in terms of intensity, this is 10 to the power of 3.5 times larger than a 4.5. Now that as a value we put in our calculator. 10 to the power of 3.5 equals 3162, roughly. Okay, so approximately 3162. So in true intensity, in terms of times stronger, a earthquake that is on the Richter scale of 8 compared to a 4.5 is 3,162 times stronger. Okay? Does that idea make sense?
Yeah.
Yeah? So Richter scale, when you jump up that scale, it isn't just multiplying like, for instance, a good example again would be difference between 1 and 2. The true magnitude of 1 is a 10. The true magnitude of a Richter scale of 2 is 10 to the power of 2, which is 100, which means that's 10 times stronger. Right? And we constantly go up by multiples of 10. So the farther you go up the Richter scale, it just gets larger and larger the magnitude that it's growing by. So there's very big differences between like 7 and 8 compared to just 1 and 2 when it comes to earthquakes.